So now let's talk about set associative caches. So set associative caches try to combine the flexibility of fully associative caches with the efficiency of direct map caches. So this is a compromise. The idea is to combine the easy searching of direct map caches and the flexibility of fully associative caches. And we do this by producing a set associative cache. So in a set associative cache, each memory address can only go into one set. So we're going to use the same modulo addressing as we did in the direct map cache, but each of these sets can have multiple blocks. So we're going to have some of this associative searching, but not throughout the whole cache. So we're going to allow each address to go into one set, but multiple addresses in each set. So this is relatively easy to search. We know which set to search based on the address, and we only have to check the few cache blocks in the set. And it's reasonably flexible. We can put each cache block anywhere in the set. So cache blocks don't have to go in only one location, they can go in any location in the set. So this is going to reduce the conflict misses. So let's take a look at set associative cache block placement. So each address is going to map to one of these sets. We're going to use modulo addressing. So address 0 is going to map to 0 mod 4, so anywhere in set 0. So note we only have 4 sets here. We have an 8 entry cache, but each set has 2 blocks in it. So we're going to have 4 sets. Address 1 mod 4 is going to go to anywhere in set 1. 2 is going to go 2 mod 4 anywhere in set 2. Address 8 is going to go anywhere in set 0. Address 9 anywhere in set 1, etc. Address 18 anywhere in set 2. So what you can see here is that every 4th cache line is now going to be able to map to anywhere in the first set. So we know which set any address is going to go into. So when we go to search the cache, we only have to search all the blocks within that set. So how do we do this? Well, I'll look at the last 2 bits in this case because we only have 4 sets, so we need 2 bits. So address 0 is going to go to set 0, address 8 is going to go to set 0. Address 1 and address 9 to set 1, and address 2 and address 18 are going to go to set 2. And you can see that by looking at the last 2 bits, ignoring the byte addressing bits, in the address. The rest of these bits, they're going to be used for the tag. So let's take a look at set associativity. So what are the benefits? Well, it's reasonably easy to search the cache. We just need to find the set, and then we look in the set. And this gives us flexibility, because we can put it anywhere within the set. The con, it's less flexible than fully associative caches. They can go anywhere. Here we can only go anywhere within the set. And it's more complex than direct map caches. We now have to check all of the blocks in the set to see if the data is in there. So let's look at the example we had before, which had all those conflict misses with the direct map cache. So here we've described which bits are used to decide which set to go into. So let's look at what happens when we run this code. So the first instruction is going to go in anywhere in set 0. So we put it in the first place. The next instruction is going to go anywhere in set 1. It's fine. Now when we have the other instructions, this instruction is going to go anywhere in set 0. Well, we have an extra space in set 0, so we can put it in there. And the last instruction needs to go anywhere in set 1. And we have an extra space there, so we can still put it in there. So what this did is the flexibility of putting data anywhere in the set allowed us to keep these in here and use the cache more effectively. Remember, in the previous example of direct map, each address could only go in exactly one location, so we didn't have any flexibility. So here, with a set associative cache, if 2 addresses have the same modulo addressing, they can go anywhere in the same set. And as long as the set is large enough to support 2 addresses, we can keep both of them. So set associative is more flexible, which means we have fewer conflicts.